Welcome, welcome, welcome. This is a Tech Talk from Wallace Ennis. I'm Johnny Mayer, Plan and Spec Salesman. Let's get started with today's presentation. Okay, so today we are going to be discussing some plate and frame heat exchangers, some shell and tubes as well. But first, Wallace Ennis. We are the manufacturer's representative for a lot of great companies, Bell and Gossett and Lochinvar, probably the biggest ones. We cover the 5 boroughs of New York, all of Long Island, and northern New Jersey, up into Westchester, a big swath of the area. Who are we? What do we do? How do we achieve success? We do that through the 360 experience. The Wallace Ennis 360 experience. At Wallace Ennis, we are dedicated to ensuring our clients, buildings, and residences provide comfortable heating, cooling, and domestic water as expected. We do this by taking a 360 approach. Understanding our customers' expectations up front, we utilize a suite of products and services throughout the project to ensure HVAC and plumbing systems are designed, installed, and maintained to reduce capital equipment costs, maximize efficiency, and extend equipment life. Our end-of-project review and service guarantee provides peace of mind that the project was completed as expected, and with long-term monitoring, ensuring future performance. We answer the call. For 95 years, we've answered your call for project assistance. Always the best. We provide the industry with leading products and services. When needed, we implement innovative solutions to meet demanding project requirements. And as anticipated, we are your trusted partner in meeting your expectations. So there's a few arms of the 360 experience. First one's Hydrosource. So this is probably what most of you guys would think is more the residential product group for developers, engineers, facility, wholesale. So we do product training, installation training, system sizing. We can offer extended warranties and all kinds of commissioning. Hydromax. Now this is more the turnkey solutions as it pertains to today's presentation. We can do a lot of plate and frame heat exchanger cleanings. We can do some monitoring, some commissioning. We can help out with anything you aren't comfortable doing. We ask that you reach out to us. We're happy to help. Hydrofab. Now this can also help. This is our new packaging endeavor. I shouldn't say new. We've been doing this for years and years and years. We can reduce costs by engineering something, eliminate the guesswork, and we've been installing this stuff all the time. We're the manufacturer's rep. We know how to install the pumps properly, the heat exchangers properly. So you get a little more peace of mind knowing that it's been done the right way. We also can meet unique requirements. Whatever you guys need, whether it's a tight fit or anything along those lines, our factory has built a ton of systems. We can fit it into your room. If there's a way in, we can do it. We fit through slim doorways. We've been lowered into buildings. You name it, we'll do it. Also accelerated timelines. We can test, build, and get these things out to you much quicker than if you stick building on site where it's a mess. You got all kinds of different trades going back and forth. Trust it to us. You're just going to drop it in, bring in your pipes. That's going to be the end of it. Our manufacturing partners, here's a list of them right here. Tisdale Modular HVAC, that's our packaging arm for what we just discussed in the Hydromax division. We're going to focus mostly again on Bell and Gossett today and the heat transfer division at that. Here's a few projects we've done. 99 Hudson specifically, I'm going to bring in a few examples of work we've done there. Hopefully some of you guys watching this video work in these projects and can attest that the packaging solutions were great, and also using our heat transfer equipment's done a lot for you. All right, so let's get started. Plate and frame and steam YouTube heat exchanger installation operation. We're going to start with the plate and frame heat exchanger installation. First of all of our units come AHRI certified. A lot of competitors can do that. A few of them can't. Please make sure you're getting the proper equipment and following specifications, especially in New York, guys. So first, we're going to get an overview of the gasketed plate and frame heat exchanger and its components. You have your guide bar on the bottom, carry bar on top. They connect to the frame plate and have a support bar in the back. The frame plate at the front, that's a fixed plate. That thing's footed, bolted in, that's solid. The heat transfer plates are in the middle. They're doing all the real work. All of these plates are considered the plate pack altogether. So that's basically, that's your medium in the middle. That's where the water is actually going through between those plates and their gaskets. At the back, you've got the pressure plate. This one actually slides on the rail. It's a bigger, thicker one you can see there. I don't think you can see my mouse, no. So that's your plate in the back, the pressure plate, and that's applying the pressure, keeping everything tight. You can get the connections on these on the front there, as you can see, a number of ways. You can get them threaded, studded, or flanged. The important thing is that when you bring your pipe in, you pipe with counter current flow. So what is counter current flow? There's a good illustration here for you. Counter current flow is obtained when a given fluid traveling up one side of the plate and the other fluid down the opposite side of the plate. The plate's chevron patterns create metal-to-metal contact points between adjacent plates for added strength. This allows differential pressure equal to the design pressure. The entire assembly is held together by tightening the bolts, and the carrying guide bars are used to obtain the proper alignment. So what you see here with the hot and the cold, you see that one is going on the bottom, the other on the top. That's counter current flow. The heat exchanger is equal on both sides. So I could switch the hot and the cold. You could switch the sides, but as long as you maintain the counter flow, meaning one's coming in the bottom, the other the top. And as you can see, this scrubs and gets the most transfer on those plates. You see going up and down either side, the hot and the cold water. That's where the transfer occurs, guys. So what clearances are required? Per the INO manual, they're going to tell you you need 1.5 width of the entire unit on both sides. The back, you need to go to the end of that carry bar, as you can see, and you need 5 feet in the front, pretty much all the time. Do you really need 1.5 clearance? No, you don't. And this wouldn't be flagged by a building inspector either. You need 1.5 on one side, and you need a few inches on the other side because the plates swing out, and you're picturing a rectangle. They connect to that top carry bar, and they swing. So when you're removing the plate, you push the pressure plate all the way back against the column, as seen in this picture here, and you start removing the thermal plates. Now you want to stack these, you want to keep these in sequence. It's very important. Not every plate in there is the same. I'm going to repeat that. They're not all the same. Keep them in order. So in this picture, you see how they sort of swing out. They're showing you the insertion. Basically, there's a cutout at the top of that plate, sort of like a hook. It hooks onto the bottom of that bar, and it swings in. So in this drawing, you can see on that right side of that, if we're facing the front plate, you're going to need only a few inches on that side. And then to the left, you're going to need 1.5. That's what you're going to need to get that plate out. Okay? So that's why we say 1.5 on one side, and you don't want to be jammed right up against the wall on the other side either. You're going to need a few inches there. So I get this a lot. Do I need an inertia base under my plate and frame heat exchanger, housekeeping pad? What do we do? I've been in this conversation a lot of times. The INO doesn't get specific. It's going to be local to your building code where you are. So some will call for an inertia base. There are no moving parts in the plate and frame heat exchanger. It's dumb equipment, if you will. There's no moving part. There's no rotating assembly. It shouldn't create a ton of motion except the water coming through on its own. So we don't recommend springs. You shouldn't need them. A standard housekeeping pad, usually 4 inches, should suffice in most situations. Again, if your engineer, your designer, your building owner, maybe depending on what's underneath the space, are requiring spring and the inertia base, then you can give it to them, but we don't recommend it necessarily. Available options on your plate and frame heat exchangers. You can get insulation from factory, so they'll give a blanket type that wraps around the pack plates. Fits nice and tight. They'll cut that for you. You can also get that suitcase style. This is exactly what it sounds like. You end up with a stainless steel rectangle. It encloses the whole thing. Depending on what temperature you're bringing through it, this can be really good if you've got a very hot or a very cold medium that requires insulation. You can put a drip pan for the same reason. Three-way reversing valve is meant to stop blockages. So basically what these do is they reverse the flow of the water temporarily through the nozzles and through some of the plates, so you can clear out any gunk by reversing the water. These are very expensive. They're very expensive. And a lot of the scaling things they prevent aren't particularly common in applications that we usually see. So if we're talking plate and frames and we're using generally pretty clean water, I don't know that it's always needed or necessary. So I'd say 90% of the jobs we use, I wouldn't recommend it. But again, if this is an item that somebody's calling for, it's something we can source for you. So instrumentation needed on either end. You need air vents on both sides at the high point of your heat exchanger. Drains and isolation in case you need to get in this thing, turn it off, and also bypass piping is needed. A lot of these are seasonal, right? we might need to go around and make sure you put in your bypass piping where necessary. Do not over tighten the plates. Do not over tighten the plates. You can crush these plates. If you just tighten those tie rods over that back plate, you will crush these plates, you'll ruin them, and you'll need to replace them. If you don't know what you're doing, taking these apart and reassembling, call Wallace Ennis. We'll do it for you. We'll set you up with someone who can do it, someone certified. We'll get certified people out in your job site. Sometimes we've had people who need these disassembled and reassembled on site to get them into a tight space or a particular room. We can do that as well. We can offer that service. We'll break it down for you. We can do it at a rigger's yard. You can rig it in pieces, bring it in. We can do it on site. Whatever your need is, we can do it. The other thing we can do, again, we mentioned this at the top, packaged options and solutions. So this is a beautiful setup here. We brought in both pumps with the VFD, all your air separator components. We got a chem feed on this one. We got all your instrumentation installed properly, and a pair of plate and frames right on the back of the skid. Bring it right in. If you've got room for this, and generally new construction you do, I couldn't recommend this more. It's going to save you a lot of time, a lot of energy. Everything's certified and built properly. We've also done these where we'll put the inertia base just under the pump portion. So we can make sure everything's, seismically rated, whatever your needs are. We've done creative solutions. All right, so now let's move over to the shell and tube heat exchangers. So on these units, the SU units, that's a steam to water U-tube unit. So SU is steam, U is U-tube. Water to water, you're gonna see a WU unit. These are not as common, so I'm not gonna touch on them quite as much. They look the same. Basically, you're bringing water into the shell and into the tubes. The steam unit's got steam in the shell, water through the tubes. Most of the time, I should say, not all of the time. So here's a look at that U-tube unit. So you've got the shell, and the shell's bringing the steam into that top flange that you can see at the top of it, and then condensate comes out of the bottom. Generally, we can change the configuration if you don't want the flange right exactly there. There are a few options available. The water is going to come in on the tube facing you. That's the tube sheet there. These are available in double wall tube construction. And we can also do high temperature. We can do some high pressure steam, but a lot of time, guys, what we're looking at with these low pressure steam, rarely do we see something over, 15 PSI. We do a ton of these, 5 PSI, 10 PSI, but 300 pound pressure on the water side is not a problem at all. So we have a gasket between the tank and the head gasket, and the head sheet, and then you've got the gasket right there for the head. You've got your tube sheet, which is basically a lot of different openings for the water to go down. It divides up between different tubes, and that way you get the best heat transfer. Here's a picture of a typical installation. There's, on your water side, you see the water's going through your regular air separation equipment and then coming in the bottom, exiting the top where there is a relief valve. The steam control valve is then tied into the incoming there, so you're getting an idea of the flow and temperature coming in. That's going to control the steam so you get proper temperature that you're looking for. So here's the automatic steam regulating valve here, and that's showing you that it's got a connection to the hot water out. So this one's controlling by the temperature there. So it's tracking the temperature on the way out and making sure you got the right temperature needed. As you see on the far left, air vent or vacuum breaker. That is where you must have a vacuum breaker installed. So accessories you need. We sell cradles or strap cradles. I'm going to show you a little bit more of that on the next slide. Basically, you can either strap this in and mount it in a ceiling, or strap it up somewhere, or you can put mounting feet on it and put it on the ground. On a steam unit, a vacuum breaker is required. What is a vacuum breaker? Well, if you have any water in the shell on the steam side, which you will, because as it condenses, it'll be on the bottom there, but it creates a vacuum effect if anything flashes in the steam within that shell, and that can be destructive. That can create a lot of damage. So this little breaker basically just vents to the atmosphere, so a vacuum effect cannot be created. It breaks the vacuum, hence vacuum breaker. You must have this in a steam application. Must. Absolutely cannot go without. And you need a properly sized steam trap, which makes sure only no steam leaves the unit anyway and gets into the water where it can flash and create damage. It has a float, so only the condensate water is leaving. So this is what the assemblies look like for the legs and the cradle. Basically, you're just going by the diameter of the unit. So you can either do that cradle and strap it up high, or you can get the mounting feet. You need to purchase 2 of these per unit. They don't sell them in pairs. I don't know why they don't sell them in pairs, because you always use 2, no matter what you're using, but you do need 2 per unit. Okay, installation notes to remember. Provide sufficient clearance of the head so you can remove the tube bundle. So for any maintenance on this unit, if it's a gasket or if you need to replace a tube bundle, anything like that, you need to pull that thing out. So make sure you leave proper clearances, and I'll show you where to find your proper clearances in a moment. Provide the valves and bypasses, so piping, so that both the shell and tube bundle may be bypassed to permit isolation of the unit for inspection or repairs. And thermometer wells and pressure gauge connections, all piping in from the unit located as near the unit as possible. So this is your typical submittal sheet you're going to get with every heat exchanger. It doesn't say your clearance in the I&O manual, but it's going to say it on your submittal. So I boxed it there in the top right corner, 52 inches required. Now, as you see, this whole unit is only 53 inches, and this is a pretty small stock unit. It's about 53 inches long. So you do need 52 inches to pull out that tube bundle, right? That tube runs pretty much the full length of the unit. More notes to remember, the condensation drains via gravity. So after the trap, make sure you have enough height to pitch properly to your condensate pump. So if you're using the legs, let's say, and it's on the ground, and your condensate pump's a long way away, you got to make sure you've got the proper pitch to get that water to gravity drain into the unit. The pump on that unit is to pump out. So, you know, you're filling that tank just via gravity. So if you look at this, you see what's located B, letter B, that's your outlet there. So you got to make sure after your trap, you got enough gravity. So there's a few package solutions we've done. We've done a million of these. There's a really nice one I'm working on right now that I'm going to show you guys some cuts on. We can do any design that's going to fit your space. You're going to save on labor. You're going to avoid mistakes. You're going to just bring in your connections. And let me show you this layout we did, because I think it's awesome. So if you can see the steam trap basically halfway down there, we've got the pump. We put an angled triple duty valve to keep this thing shorter. All your air separation equipment and your pot feeders all right here. So that's feeding into the water side, and then you've got your hot water out flange facing upward at the top of that thing. Just a beautiful design. And you'll see that trap, like we were just talking about, it's about halfway up. So you got plenty of height to pitch that to your condensate pump. So all you got to do is pitch that to your condensate pump, bring in your steam up top, and pipe out your hot water, and you're done, guys. You're done. And this thing's packed nice and tight. You can fit this in any boiler room. It's a ton of equipment on top of each other as long as you have the height. This is a beautiful layout. So I really do recommend for these shell and tube installations. And we've done ones with, you know, if there were 2 shell and tube units, we can put them side by side there. Plenty of room for pull out. So make sure you leave that on the front. You got room to access these pumps as well. And the whole thing fits in beautifully. We've just demonstrated the latest technology and the best state-of-the-art equipment for overall efficiency and return on investment. I think you would agree that investing in a quality product like we have shown you makes sense, don't you? Yes, thank you. So I can count on you to use our brand for upcoming projects, correct? Guys, thanks a lot for tuning in again. My name is Johnny Mayer, and we'll see you next time.